Hello everyone. So today we are going to discuss about the most important topic. The topic is limiting reagent. From this topic, every year one question definitely asked by the examiner. It may be related to the J exam or it may be related to the NEET exam. Okay. So if the question given to you related to the chemical reaction, okay, so there is only two possibilities. If it is a physical question, physical chemistry question, so there is only two possibility. It may be related to the stoichiometry problem or it may be related to the limiting reagent. So first of all, we have to distinguish the given question is related to the limiting reagent or the stoichiometry. Okay, so there is some condition. Okay, let's discuss limiting reagent. Okay, so what are the conditions? Through this you can identify that the problem is related to the stoichiometry or the limiting reagent. Okay, so the first condition is if only one reactant is given, for example, calcium carbonate dissociate into calcium oxide and CO2. Okay, so reactant is only one and the product is more than two or three. Okay, so in that situation, this problem never be related to the limiting reagent. Okay, this type of problem is never related to the limiting reagent. This type of problem is related to the only stoichiometry. Okay, not the limiting reagent. The first condition is this, and the second condition is at least two reactant is given. For example, like we can say N2 3H2 give you 2NH3. Okay, so the second condition is at least two reactant and their amount means like weight is given from the both the reactant, weight given or the volume given, or the like we can say mole is given to you, or space means weight, mole, volume. Okay, if both reactant volume is given or the weight is given or the amount is given, then this problem may be related to the limiting region. Okay, not sure, may be related to the limiting region. Okay, but this type of problem never be related to the limiting reagent problem. Okay, it is fixed. It is related to the only stoichiometric problem, not the limiting reagent. Okay, okay, but this type of problem, if more than one reactant is given and their amount is given, then this problem may be related to the limiting reagent. Okay, not sure. Okay, we through question we can discuss that how you can identify this type of problem is related to the limiting reagent or not. Let's take the example. For example, okay, if 3H2 and N2 is given to you and 2NH3, okay, and weight is given, we can say that like 6 gram, H2 is given, and 14 gram N2 is given. Okay, so the step one, first of all, you have to be convert everything into the mole. For example, if weight is given, then convert into the mole. If the amount is given, convert into the mole. If the volume is given, then convert into the mole. Okay, so this is the step one. Step one, convert into a mole. Whatever the thing is given to you, it may be the amount or the weight of the reactant or the volume of the reactant. Okay. So mole of the H2 is 6 divided by 2. So we get 3 mole. Okay. And mole of N2, 14 divided by 28, we got 0.5. Okay. So we got 3 mole of H2 and 0.5 mole of N2. Okay. If the directly mole is given to you in a question, then no need to calculate the mole. Step 1 is already completed. Okay. So this is the step 1. Whatever the thing is given to you, convert into the mole. It may be amount, it may be weight, it may be volume. If the mole is given, no need of a step 1 process. Okay. Now, when you get the mole, then moving to the second step. The second step is we got the mole, 3 mole of H2 and the 0.5 mole of N2. Okay. So the step 2 is identifying that this problem is related to the stoichiometry or the limiting reagent. Okay. For example, first of all, we have to take the ratio. Okay. How to take the ratio? Mole of H2 divided by 3. We take the ratio like mole of the reactant divided by their stoichiometry. Okay. And from both reactant. Okay. A mole of N2 divided by their stoichiometry. If both the ratio means mole of the one reactant when we divide with their stoichiometry is equal to the when we divide the mole of other reactant with their stoichiometry, if both that ratio are equal, then the problem is related to the stoichiometry. If they are not matching, then problem related to the limiting reagent. Okay. I hope this point is clear to you. Okay. If when we take the mole of one reactant dividing with their stoichiometry, so the ratio is equal to when we take the another reactant and we take their mole and divide with their stoichiometry. If both the reactant ratio are matching, then that problem is related to the stoichiometry. If they are not matching, then this problem is related to the limiting reagent. Okay. Through that, you can identify that the problem is related to the stoichiometry or the problem is related to the limiting reagent. Okay. Now we are applying this step on this reaction. Okay. So a mole of H2 divided by their stoichiometry, so we got 3 by 3. Okay. And the mole of N2 divided by their stoichiometry, so we got 0.5. So the ratio are not matching. That means this problem is related to the limiting reagent. Okay. So those are in a lesser amount. Okay. We got one. Okay. We got one ratio, and from this side we got 0.5 ratio. Okay. So those having a lesser amount, so that is limiting agent. Okay. The ratio of the limiting agent always lesser. Okay. And so we can say that N2 is a limiting reagent. Okay. I hope this point is clear to you. Okay. Now we get the clarification about the reaction, that this reaction is related to the limiting reagent problem. Okay, and we also identify that N2 is the limiting reagent. Okay, now move to the next step. The next step is, okay, next step is, now we are calculating the mole of the product. Okay, definitely, like if the question is asking to you related to the limiting reagent, so definitely they will ask about the amount of the product, weight of the product, or the mole of the product, or volume of the product. Okay, so definitely they will asking about the weight, mole, or these all things related to only to the product. Okay, not related to the reactant. I hope this point is clear. Now, the step 3, we are going to calculate the mole of the product. Okay, so now this is N2 is the limiting reagent. Okay, now we are going to calculate the mole of the product. Okay, so first of all we have to establish the relationship in between the reactant and the product. Okay, so obviously those are in a lesser amount, only that can decide how much product will form. Okay, so also in that situation, the ratio of the N2 with their stoichiometry and the ratio of the mole of the product with their stoichiometry, they are equal. Okay, so the mole of N2 divided by their stoichiometry 1, and the mole of the NH3 divided by their stoichiometry 2, definitely they are equal. Okay, so when we put the value, mole of the N2 we have 0.5 divided by 1, and mole of the NH3 divided by 2. Okay, so we got the mole of NH3 is 1. So we get the mole of the product. Okay, if the examiner asking you how much mole is standard, so this is your final answer. Or if the examiner asking to you calculate the weight or the volume or the amount, then move to the fourth step. Okay, the fourth step is, now finally we get the mole of the product is 1. Okay, now the step 4, in that step we are calculating volume of the product, weight of the product, or amount of the product. Okay, if the examiner asking you related to the calculate the weight or the amount or the volume, then we move to the fourth step. Otherwise the third step is the final step. Okay, if the mole is asking. Now, okay, so we know that weight is equal to molecular mass into number of moles. Okay, so 1 divided by 17, so we got 17 gram. Okay, volume, so N into 22.4 in STP condition. When we put the mole of the product, then we get the volume. Okay, if they are asking about the molecule, then multiply with 6.023 into 10 to the power 23 into mole. Then we get the number of molecules. Okay. Thank you.